Good afternoon, everyone, and thank you for the opportunity to present our work here. Thank you very much. So I'm Andrea Lumini, PhD and REAACH Fellow from the Department of Architecture of Florence, and together with Matteo Bigongiari, we will try to talk about the first results of the paper we presented, which is about a project that is still a work in progress, aimed at the experimentation of workflow for the integration between scan-to-BIM techniques and VR systems, in order to support activities of documentation, analysis, and valorization of the architectural heritage, with particular regards on the military fortification of Piombino. This research was conducted as a follow-up to some of the results obtained within the project LEOARC 3D, Leonardo da Vinci Military Architect in Piombino, a project for the urban enhancement of the city's Renaissance fortification, co-funded since 2022 by the Tuscany region and the University of Florence within the Giovani C program, and concluded a few months ago. This project, which incorporates some of the results of a research on Piombino that has been going on since 2019, which also led to the doctoral work conducted by Matteo Bigongiari on Leonardo's activities as a military architect in Piombino. This project has deepened the studies on the system of military architecture present in the city, designed in the early 16th century by Leonardo da Vinci on behalf of the Republic of Florence. And through a multidisciplinary workflow based on archival researches, digital survey, and 3D virtual reconstruction, the goal of the project was, in fact, to define a series of guidelines for the rediscovery and valorization of Leonardo's architectures and intervention through interactive dissemination system. During the first phase of this project, which was the basis for our research, an extensive archival study was carried out with the goal of defining a reliable outline of the evolution and development of Piombino fortification in regard to Leonardo's design interventions. And in particular, it has deepened the study of the Madrid Codex II, on which Leonardo described through drawing and sketches, not only the intervention carried out, but also, let's say, the surveys he conducted for these projects. The second phase, which was more operative instead, involved the geometrical morphological documentation of the architectural apparatus of Piombino related to Leonardo's defensive fortification, carried out through integrated data acquisition techniques, such as laser scanner, as you can see here in this image, showing the global point cloud of the urban perimeters of the fortification and its main defensive structures, such as the castle, the citadel of the Rivellino, but also through structure from motion photogrammetry techniques to acquire the color and the material data of these structures, as you can see here for some of the bastions of the citadel defensive walls. These massive acquisitions were then represented graphically by means of the canonical technical drawings, such as wireframes on the photo plans of elevation, section, and plans, through which it was developed a sort of a 2D graphical atlas of the survey drawings. And in this sense, these graphical and dimensional results were used to conduct a comparative critical analysis between the digital survey data and Leonardo's data. Through a careful alignment work between the various sketch drawings and the technical drawings, such as plans and sections, it was possible to understand, let's say, Leonardo's design techniques and his ideas in the field of military fortification for Piombino. These results were then used to define a series of simplified 3D virtual reconstruction of the defensive architecture of Piombino, realized or only just conceived by Leonardo, thus establishing the basis for the definition of guidelines protocol for their valorization through virtual fruition system. In this sense, the paper we presented intends to deepen further these issues by proposing a series of HBIM-to-VR procedures on one of the most, let's say, iconic structure of Piombino, such as the defensive complex formed by the Rivellino and the Porta Terra, of which we can see here a point cloud image in its location in the map. And even though probably it was not directly designed by Leonardo, it fits deeply into the historical and design context of the Leonardian intervention for the defensive consolidation of the city system. Well, as we said, from a methodological point of view, the workflow is similar to the one of REAACH 3D. It starts from the documentation phase, archival through the study of the Madrid Codex II, and architectural through digital survey, while the next step involves scan-to-BIM modeling and virtualization within a VR platform. Well, these last points, as you will see, are still work in progress, but the goal is exactly to develop a VR experience or an architectural visualization system for the direct interaction with the HBIM information metadata associated with the models in order to lead to the virtual rediscovery of the defensive architecture of Piombino. With regard to the archival study, we mainly use the open source digital platform ILIO, developed by the Biblioteca Leonardiana, within which it was possible to view and query the pages, the actual pages of the Madrid Codex II and many other Leonardo manuscripts with all of these inscription and drawings. And this research has made it possible to reconstruct the historical and projectual evolution of the architectural complex and its relationship with the other defensive structure in Piombino. Instead, with regard to the step concerning the digital survey of the Rivellino, it was conducted with a terrestrial laser scanner, a ZF 5016, through which about 80 color scans were acquired. And here we can see the point cloud of the road to the Porta Terra. And here the global point cloud of the complex with all of its component and exterior contacts. Well, in parallel with laser scanner survey, it was conducted also a series of structure from motion photogrammetric acquisition through a Sony Alpha 7 III, which made it possible to record more accurately the colors and materials of the Rivellino's wall structures. And the various point cloud models were then processed integrated with each other within the Leica Cyclone management software and then exported within RECAP Pro, thanks to which it was possible to use the global point cloud to carry out the scan-to-BIM modeling processes within Revit, which was the BIM authoring software we used for this work. So with the support of this data, it was carry out the next phase dedicated to the HBIM modeling and virtual reconstruction of the Rivellino, where the relevant heterogeneity of the elements, mainly due to the multiple transformation that the complex has undergone over the century, allowed us to test processes for translating the instrumental metric data into parametric and informative models. In particular, various scan-to-BIM approaches were considered, such as parametric adaptation of system families, creation of adaptive models, such as for the vaults, and local modeling for components with complicated morphology. The HBIM model process were then followed by those dedicated to the information data enrichment. And in particular, we define specific shared parameters to be associated with each element in order to classify them according to the following macro categories: anagraphic, dating, structure, and diagnostic. These textual and graphical parameters, such as description, construction phases and techniques, or state of preservation, thus made it possible not only to enrich the HBIM digital twin database, but also to prepare it as an information base to be eventually queryable in other platforms. In the same way, the respective archival data developed by Leonardo were then linked to the HBIM model in order to make it queryable from this point of view as well. In the same way, a series of simplified reconstructed models were also developed, always within Revit, in order to make more readable the architectural development of the complex. So in conclusion, as we said, the final step of our research are still a work in progress, but they can be listed as follows. The HBIM model text will take place within Twinmotion, importing the HBIM model through the DataSmith plugin. and it will involve the creation of specific materials based on photogrammetric data in order to be applied photorealistically to the model surfaces. The second step regarding the VR optimization will take place instead within Unreal Engine, still through the DataSmith plugin. It will involve the graphical optimization of the virtual scene and its real-time architectural visualization. In parallel, the virtual fruition platform will be developed through visual programming scripting and will allow not only to navigate the model and its component, but also to interact with its informative metadata, thus creating an immersive VR experience dedicated to the rediscovery of the architectural complex through direct and real-time interaction with the HBIM models related to the actual state of the Rivellino, its evolutionary phases, and even the reconstructive project state based on Leonardo sketches data. Finally, we think that this can become a methodological case study to expand this experience to deliver to the entire fortification of Piombino and possibly integrating in with the georeference GIS tools. Lastly, and I conclude, our research, even if it's still a work in progress, try to highlight the methodological potential of the integration between parametric scan-to-BIM modeling and VR system in order to enrich the understanding, the fruition, and the public engagement of historical structures, such as the Rivellino of Piombino, by a wide user base, technical, historical, touristical, but also to identify new tools and opportunities for the valorization and dissemination of cultural heritage. Thank you. Thank you very much.